The universe, as vast and mysterious as it is, continues to unfold in ways that are both marvelous and mysterious at the same time. Over the centuries, our understanding of its fundamental nature has expanded, but as we peer deeper into the cosmos, we encounter more questions than answers. Observations from today show that the universe is not just expanding, it's accelerating, and this raises fundamental questions about its ultimate fate. At present, we find ourselves in what is known as the Stelliferous Era. This period of the universe's evolution is characterized by the formation of stars from the interstellar gas that fills the space around us. This raw material for star formation is abundant, and new stars are continually born from it. However, the Stelliferous Era is not eternal. It is expected to come to an end in approximately 1 to 100 trillion years from now. Once all the interstellar gas has been used up, star formation will cease, and the cosmos will enter a new stage. By then, our Sun, along with the vast majority of the stars in the universe, will have exhausted their nuclear fuel. When that time comes, our Sun will transform into a red giant, shedding its outer layers and eventually collapsing into a white dwarf. The white dwarf will then slowly cool and fade into what scientists call a black dwarf. Similarly, other stars will follow a similar fate. Some will become neutron stars or black holes, depending on their mass. The processes that govern the evolution of stars are intricate, but they all share the same ultimate end: the transformation into objects that no longer shine with the light of life. The next stage in the universe's evolution is what scientists call the Degenerate Era. This period will be defined by the absence of new star formation. The universe will become populated by dead stars in various forms: white dwarfs, brown dwarfs, neutron stars, and black holes. These objects will continue to exist for an incredibly long time, but they will eventually cool down. For example, white dwarfs will gradually give off their heat through radiation and eventually become black dwarfs, cold and dark remnants of once thriving stars. Brown dwarfs, objects that never quite had enough mass to ignite nuclear fusion, will also cool down, and their slow, sluggish thermonuclear reactions will come to an end. The universe will become a much quieter place as it enters this era, but the processes of cooling and decay will unfold over an unfathomably long time span, on the order of 10 to the power of 40 years. As these stars fade away, black holes will become the dominant cosmic structures. Neutron stars and black holes will persist for a time, their gravitational forces continuing to warp space around them. The fate of matter in the universe will also become more bleak. As the Degenerate Era progresses, most of the matter in the universe will eventually be pulled into black holes, where it will be swallowed by their immense gravity. This process will slowly deplete the universe of any remaining matter, leaving behind only the remnants of stars and other objects that have long since stopped functioning. In addition to the cooling of stars, another major process will occur in the Degenerate Era: the annihilation of dark matter and the disintegration of protons. Protons, the building blocks of atoms, are among the most durable subatomic particles in the universe, and their expected lifespan is on the order of 10 to the power of 41 years. However, even protons will eventually decay. When they do, the universe will be reduced to a state where only elementary particles remain floating freely through the void. Neutron stars and black holes will persist, but they too will eventually fade away, leaving behind a universe that is eerily empty. Next comes the black hole era, a period in which black holes will dominate the universe. According to some theories, black holes will form clusters and eventually merge into one enormous supermassive black hole. Other theories, however, suggest that the black holes will slowly evaporate due to a process called Hawking radiation. This phenomenon, named after physicist Stephen Hawking, is a quantum mechanical effect that causes black holes to emit radiation and slowly lose mass over time. The smaller the black hole, the faster it will evaporate. Over the course of 10 to the 100th years, all black holes in the universe may eventually evaporate completely, their mass and energy dissipating into the surrounding space. As the black holes evaporate and matter in the universe becomes ever more diffuse, the universe will enter an even more desolate phase. The universe will be filled with only elementary particles: photons, neutrinos, electrons, positrons, and quarks. Collisions between electrons and positrons will result in annihilation, converting their mass into energy, further reducing the amount of matter in the universe. In this scenario, the universe could remain in this state for an incredibly long time, possibly even eternally, as there would be nothing left to disrupt the quiet, dark expanse. But what will come after the black hole era? Some theories suggest that the universe could reach a state of heat death, where everything is evenly spread out and there is no usable energy left for any processes to take place. This would be a time when the universe is effectively dead, with no stars, no planets, and no potential for life or any meaningful activity. However, this idea of heat death is just one possible fate of the universe. The Big Rip theory, for example, posits that the universe will continue to expand at an accelerated rate until the fabric of space itself is torn apart. In this scenario, galaxies, stars, and even atoms could be pulled apart by the ever-expanding space. The most dramatic of the theories, however, is the Big Crunch. According to this hypothesis, the universe will eventually stop expanding and begin contracting. This could happen if the force of gravity, exerted by all the matter in the universe, overcomes the expansion caused by dark energy. If this occurs, galaxies will begin to move toward each other, eventually colliding and merging into one supercluster that fills the entire universe. As the universe contracts, it will heat up, and planets, including Earth, will be burned and melted in the intense heat. The universe will continue to shrink, eventually collapsing into a singularity, a point of infinite density and temperature similar to the state the universe was in at the moment of the Big Bang. An interesting variation of this idea is the Big Bounce theory, which suggests that after the universe reaches its state of singularity at the end of the Big Crunch, it will be reborn in another Big Bang. This cyclical process could repeat itself, with the universe expanding, contracting, and rebirthing itself over and over again in an eternal cycle. While this idea is fascinating, it raises questions about the nature of time and space, especially in a universe where these concepts may no longer function as we understand them. Would time itself reset with each cycle? Could the universe undergo an infinite number of cycles, each with a new set of galaxies, stars, and planets? The possibilities are endless. It is important to acknowledge, however, that we are still in the early stages of understanding the nature of dark energy, the mysterious force driving the universe's accelerated expansion. Our knowledge is still too limited to confidently predict how the universe will evolve. Will dark energy continue to accelerate the expansion of space, leading to a big rip? Or could it eventually reverse course, causing the universe to contract into a big crunch, or even a big bounce? These questions remain unanswered. What we do know is that humanity's existence is a fleeting moment in the grand timeline of the universe. Our planet will remain habitable for another billion years or so, after which the ever-intensifying glow of the sun will make Earth uninhabitable. The sun will eventually evolve into a red giant, engulfing the inner planets, including Earth, in its fiery embrace. After that, the sun will shed its outer layers and become a white dwarf, a cold, inert remnant of its former self. The life of Earth and of humanity will be long gone by then, but the universe will continue to evolve, its fate unfolding in the distant future. Even if the universe does experience some form of rebirth after its ultimate collapse, it is difficult to imagine what this new cosmos might look like. Could life ever emerge again? Would it be similar to life as we know it? Or would the conditions be so radically different that life, as we understand it, could never exist again? We will never know, as we are confined to the brief moment in time during which life is possible on Earth. The mysteries of the cosmos are beyond our reach, but the pursuit of knowledge continues, and new discoveries are made every day. In the end, the ultimate fate of the universe may remain beyond our comprehension, but that does not diminish the importance of our ongoing quest to understand the cosmos. As we continue to explore the stars, unravel the secrets of dark energy, and search for answers to the most profound questions about our existence, we are reminded that the universe is vast, mysterious, and full of wonder. Even in the face of the unknowable, humanity will continue to look toward the stars, striving to unlock the secrets of the cosmos, one discovery at a time.